Cool. So yeah, welcome back, everyone. I hope that break was more invigorating than the greenfield project that I had to deal with when I landed on site here that we're going to talk about in a minute. So yeah, I'm Steve Wade. I call myself the kind of cloud native catalyst because I end up turning kind of legacy nightmares into cloud native dreams, and we're about to go on one right now. But you might all be thinking like, oh, this is another GitOps talk, like perfect for an afternoon siesta. But I promise you, like by the end of this session, I'm going to try and have you at least half awake. And like rethinking your entire approach to how you're doing GitOps. Is this working? Yes. So I want to start by setting the scene. So picture this. I'm on site, FinTech venture, within a bank that's like centuries years old. Like I'm talking like older than some countries, right? And the mission is to drag this institution from some ancient way of doing things into the new digital age. Right, and I was like, oh, this is like an awesome contract. Like, it sounds absolutely thrilling, right? Great project for me to get started with. Now, like, add in warring development teams, infrastructure held together by duct tape, and a production environment kind of so fragile that like a stiff breeze would probably like bring it down. Today, I'm not kind of sharing with you a story. I'm going to try and hand you a blueprint, right, from like turning a tech nightmare into some kind of cloud native dream. So yeah, we are implementing this kind of shiny new tool, but this is more of like an engineering big bang reculturization, where we turn the phrase that you're going to commonly see as "we've always done it this way," which is practically carved in stone in this institution. So before I dive in, I want this to be completely interactive. So feel free to get out your phones. I encourage it, right? Ask questions. There's going to be a Q&A section at the end because I'm never going to fill 55 minutes and you're going to get bored of my voice. So we're going to do a Q&A section at the end. You can upvote and downvote the questions that you have. So I'll take them in priority order. And if I don't get to them at the end, come and see me afterwards. I'll be around until the end of the conference. All right, has everyone taken the photo? Okay, so the journey from kind of chaos to clarity wasn't a straight path that this depicts. It was more like kind of navigating a labyrinth in the dark, to be honest. We started with the chaos, which was like the legacy that I was handed the day that I joined on site. And then stage 2 was like this awakening, which we'll kind of get into, which was the moment of brutal honesty where everyone actually started and needed to take note of the state that the environment was in and actually do something about it. And then we did strategy, which was obviously like charting the course through these uncharted waters of how we're actually going to fix this big, complete mess. And then like my favorite stage personally as an engineer, which was like building out the plane whilst we were flying it. And then finally we did like, we recompiled the engineering, the operating system of the organization. So when we dissect each of these stages, I want you to place your organization on this map, right? Are you drowning in inherited chaos like I joined? Or are you kind of starting at the precipice of your own transformation? And I know you're about to start one soon, so you're somewhere on this map. And remember, in the tech field, like if we stand still, we're actually moving backwards, right? So stage 1 is chaos. So I said, like when I joined the FinTech venture, I didn't just step into a project. I stepped into what I call a legacy of well-intended decisions that have gone awry. So some of the kind of challenges that the team were facing were kind of microcosms for like the tech industry today. And this was the kind of start that I started with, right? So we've got developers, and this is me as the platform team over here. And we were once united in purpose, right? But now we're kind of eyeing each other across a battlefield of blame. And it wasn't like a communication barrier. I'm not kidding you. It was like a full-on war. Developers saw themselves as these kind of innovators that were held back by bureaucratic gatekeepers. And the platform engineers, well, they just were viewed as bad people that all they wanted to do was make sure that their thing was absolutely perfect and you couldn't possibly deploy your workload onto it because this is a sacred platform. But in the era of agility, right? Agility is king, so we actually need to be able to move. And right now, these were just kind of stuck in the mud. They weren't going anywhere. Developers would blame platform team would blame developers. Constant cycle, no one really went anywhere. So imagine now like building the future of banking on like this foundation of clicks, right? Not kind of strategic, well-documented clicks, but like panicked Steve, can you do this yesterday? Clicks in a console, right? Sound familiar? Hands up if this sounds kind of semi-familiar. Yeah, this wasn't a bad practice. This is like playing digital Russian roulette. These clicks were like landmines, right? They were like armed and waiting, and we had a fair few of them, and they're about to come up during this talk. But what we had to remember, and I think, Matt, you said it earlier, right, is that we're playing with people's livelihoods, right? It's a financial institute. We're playing with people's money. We need to build this thing on a stable platform and a stable foundations, and then we can kind of innovate from there. So our deployment process kind of wasn't just risky. It was a bit like this, right? It was a high stakes game in which we'd bet with the user's trust of whether the deployment would actually work or not. And documentation was kind of this luxury that we said, we'd get to it at some point. Like it's not really that important right now. We just got to keep moving, got to keep shipping these features for our customers. And then like having a rollback plan was just like this nostalgic memory that we would eventually, have something. Who needs a rollback plan? We're just going to constantly keep moving forward and pushing forward because nothing ever needs to be rolled back, right? And then each deployment was kind of like this leap of faith where everybody from like the interns that were working in the team that I was working in all the way up to the C-level were kind of like holding their breath every time we did a deployment, hoping that nothing would go wrong. But yeah, like I said before, we needed to stabilize the system, and the kind of irony was palpable that the system wasn't stable at all. And then 1 week in, like I actually witnessed the fragility of the system firsthand. So take an example of a production AWS estate with a number of security groups. By a number, I'm talking like 50. How you need 50 security groups for a little Kubernetes cluster, I have no idea. But anyway, let's just kind of gloss over that. Someone decided that they were going to go into the Amazon console and clickety-click and change a couple of the security groups. Like, what could possibly go wrong? 12 hours of chaos and like a crisis and halted revenue and customers couldn't log into the application. And this was just like the most tiny change that they made, but it was a kind of stark like an understanding of the responsibility that we had as engineers dealing with people's finances and financials money. So like the chaos was completely unsustainable, right? And it was also like ethically questionable. So every time we had an incident, we had to report it to the FCA, right? When we miscorrectly calculated people's invoices or when we were displaying the wrong balances for a period of time, we had to report all this. So someone's naive security group click turned into myself and a bunch of other people having to go sit in front of a boardroom and feel a bit like Boris Johnson when he was talking about COVID, about what was going on and why we kept on having these issues, right? And then we found ourselves in this kind of innovator's paradox, right? We were tasked with building the future of banking, but we were barely managing kind of today's technology and today's infrastructure. And this, to kind of give you a scenario, this company was only really, the venture was only going probably like maybe 18 months, maybe 18 to 20 months from the time that when I landed on site. And the chaos wasn't kind of born from laziness or like incompetence. It was really like a byproduct of the passion of the team just wanting to move forward. But the problem was that the ground beneath their feet was so unstable that they couldn't actually move forward because every step forward, was like 5 steps back once it actually got to production. So we had to fix it, right? But we're not kind of just fixing something relatively trivial. We're trying to perform open heart surgery on a marathon runner whilst he's running. It was borderline impossible. So we got to this stage, right? And it's the stage that I call the awakening stage. So I want you to picture this. So it's Tuesday morning. I'm 1 month into my tenure, and in this 1 month, my job was to go around all of the teams and figure out what the hell was going on and why there was so many issues. And we're in a boardroom, there's a number of people in there, a bunch of senior executives, and the CFO just kind of asks like one simple question that would prove to be like what I called the Apollo 13 mission. All he asked was this, right? How long would it take for me to rebuild our production environment if we lost it all tomorrow? Because he probably thought we were going to lose it all tomorrow because we were having so many incidents. But little did we know that this was going to be the catalyst for a complete revolution of the company that I was in. It wasn't just a small, minute change. It was a massive change on the way that we did absolutely everything. So, like 5 seconds of silence honestly felt like about 5 weeks and we were exposing our fragility in front of senior level executives. And I was kind of scanning the room like this, right, hoping that someone would say something. Just give me something to lean on here. Give me some answer, make up an answer, tell him it's going to be like 4 weeks. Just please, God, say something, because I can't say anything. But it proved that there was a huge amount of gap in the knowledge that we had, right? We knew how we deployed things because certain individual worked in certain team, and he or she was the person that we went to be able to deploy the applications to production. And then we had someone that would deal with security group issues, et cetera, et cetera. But what we needed to do was, this was really more about getting everybody on the same page, right? And actually harmonizing and bringing in this culture where, I'm going to steal your phrase, where everybody has fractional ownership. And if you came to Matt's talk, he said that, and I've now coined his term. So thanks, Matt. So the question was so straightforward, right, in hindsight, but it was like kryptonite, because it dissects the whole digital dilemma that we had going on, right? We had no infrastructure as code. If the person or people were here, they would say that they had infrastructure as code. I have a slightly different understanding of what we mean by infrastructure as code, and they definitely didn't have it. It was more like a digital Jenga tower, right, where it was just prescribed by a bunch of clicks, and those clicks, like we said, weren't documented. And the clicks that you had in production may or may not be the same clicks that you made in staging, right? So we've got kind of this environmental schizophrenia, where our three environments are like distinct cousins rather than triplets of what they should be. And then each release that we had, like we kind of go back to before, was like this unique snowflake where everyone would kind of like just clamber behind the desk when we were doing production releases. And I remember specifically we did a production release whereby we were changing the way that the invoicing system worked. And we practiced it a bunch of times in staging, and we went to the product manager and we said, look, it's going to take us about an hour and a half to do this. We've done it 5 times in staging. Nothing's going to go wrong. We're fine. Yeah, we were completely wrong with that statement. Production looked nothing like staging. Staging had different security groups. The data that was in staging had been upgraded to look different to production. Did the production migration get run? Of course it didn't, because we didn't need to practice it in staging. Right, and it was just a snowball and catalogue of these problems that we kept on going along the way. And then we kind of had this curse of tribal knowledge, and I know you learned about this before, right? These processes lived in people's minds, and if those people weren't there, then we had no process, right? And it was just kind of YOLO it all the way to production and kind of see what happens. And remember, we'd always fix forward. And disaster recovery was kind of this theoretical concept, right? We planned to have a plan at some point, but we never actually used the plan or practiced the plan. But don't worry, CTO, we have a plan. How long will it take? Unknown. And we had like this kind of marathon strategy, right? Where we had this hidden cost of iteration, because we needed to move so fast to be on the bleeding edge and give customers new features, et cetera, et cetera, et cetera. And if you looked from the distance, it looked super, super impressive. But actually, if you were on site, it was absolutely terrifying, because every day was just like a lottery of whether you were going to be in an incident or not. So, 2 words, 5 letters, right? Simple. A whole entire organizational revolution kind of wrapped up in 2 words. So the CTO looks across the table at me like this and says, this is your task. Do with it what you will. Come back to me when you fixed it. What I just kind of said, all right, but what he doesn't realize is I'm opening Pandora's box, right? There's technical debt, there's cultural rifts, there's organizational chaos, we've got a bunch of people that we need to hire because a bunch of people that should have been there are not there. So, in essence, this kind of wasn't a task, if you think about it. It was kind of a North Star of where we needed to go. So this was my answer to him. So that may seem ridiculously flippant, right? And kind of an underestimation of the task. But this task was huge, right? And he kind of knew it. He wouldn't admit that he knew it. He just said, you've got to go and figure it out. This is why we brought you here in the first place. But with a lot of complex problems, if you just break them down into a lot of small tasks, and by a lot, I mean a lot of small tasks, you can eventually get to where you need to be, right? And it's just a case of taking stepping stones and working on these things in kind of manageable chunks. So this cool simples was like the new way in which we were going to drive everything. It was going to start the journey of transformation. So, like I said before, right, that was our kind of North Star, right? We had to be able to rebuild our whole entire production system from scratch. But obviously we had to start with being able to rebuild our whole entire development from scratch, and then we go to staging, and then we go to production. And you can probably see where this is going, because I said schizophrenia in all of the environments. So none of the environments look the same. So it's essentially completely restarting again from scratch. That was the only way that we could do this. We had to leave what was currently there, rebuild the plane over here, get the plane to take off, and then somehow mid-flight, like transition all the passengers across. So kind of enter GitOps. So right, I know what you're all thinking. Right, great. Steve said GitOps. It's another like tech buzzword that I can tick off my buzzword bingo card. Right, and it actually is. But I want you to kind of hold your marker pens, because it's not a buzzword for this company specifically, and the companies that I work with in the past. It's like a fundamental shift in how everything gets done and how you approach and lead like a technical organization. So this was me, right? I started my life as kind of a developer, then I went into platform engineering, and then I started checking out this thing called GitOps. And I said, you know, this was me reading the documentation, and then kind of moments later, as a kind of battle-hardened platform engineer, I kind of saw the future unraveling in front of me, and I said, you know what? I'm all in. Whether it's the right decision or not, he's not going to care. As long as I can give him an answer in a couple of months, we're golden. And if the worst thing comes to the worst, it's going to look good on the CV, right? I transformed something with GitOps, whether it failed or not. Nah, who really cares? I'll just gloss over that. So, like, discovering GitOps to me was like discovering this kind of Rubik's Cube, right, that I'd been madly trying to solve for like many, many years. And I kind of realized that we could leverage this new tool. So, what did we need to do? So, as I alluded to before, we're not kind of sticking a plaster on this problem, right? This is a total restructuring of the organizational DNA. We needed an approach that could be completely different, and I know you talked about it before, right? We've got to unify these fragmented teams into some kind of cohesive force that actually liked to talk to each other, not point fingers at each other. We needed to turn our infrastructure from this kind of mystery into this well-documented, reproducible system that actually gave us some kind of level of confidence so that we can answer Mr. CFO's question when he comes and asks us. And then, most importantly, we had to change our confidence from like, I hope this works, to I know this works. And that's much, much harder than you think it is, to be able to give yourself that level of confidence. And I remember I was sitting in a room with this gentleman, the CFO, and he was like, so what's your plan? How are you going to fix it? And I said, well, you know, I'm kind of playing four-dimensional chess, to be honest with you. I'm not really sure, right? There's complexity, there's dynamics, and there's like me in the back of my mind thinking that this is seemingly impossible, but he's got me on site to try and fix it. So we've just got to naively go forward, and hopefully we go forward in the right direction. So we kind of enter in GitOps now, right? And GitOps wasn't just kind of for code. It was like this grand conductor of our entire enterprise organization. And we're talking infrastructure, we're talking platforms, and we're talking these applications that kind of perfectly play in harmony with each other. But it's the single source of truth that we're going to run for everything, right? So we've got somewhere where we can point back to. We can say it's there. Every change, every configuration, every deployment, every rollback, every stupid mistake that Steve made when he was trying to do this in the first place, it's all tracked, versioned, for better or for worse, in some kind of commit history, right? And this wasn't kind of just about improving the workflows that we had. It was like, how did we interact with each other in some kind of cohesive, coherent way and be able to point back at things when C-level executives were asking us a bunch of questions. So GitOps is just a set of practices, right? It's like a philosophy that I feel personally is built on these four pillars. So we've got declarative. Well, that's obvious, right? We all speak the language of kind of outcomes. We tell our system what we want to do. We don't tell us kind of how we want to do it. Then we've got versioned and immutable. Well, like every change is reflected in history for better or for worse, right? We preserve the history of our environment's evolution, all the good things, all the bad things, and everything kind of in between. And then everything is going to be pulled automatically, right? So our system's going to be this kind of living entity where we define what we want, and we're going to hopefully get it into that kind of state. So you'll hear the word desired state configuration. That's essentially what we're going to do. We're going to state how we would like the system to be, and then the tool's going to try and get it into that shape, right? So these are the kind of pillars that we're going to lean on, but like, how did we actually implement this thing? And this is the part that everybody wants to get to. So we're going to kind of dig into the trenches of actually how we did the implementation. So as exciting as kind of GitOps sounded, right, we already knew that this wasn't going to be a walk in the park. It demanded kind of new tools, like a fundamental shift in how we did absolutely everything. But the promise of transformation was like too powerful for us to ignore. Like, we knew we had an absolute ton of work, but if we got to the other side of it, we'd be able to answer the CFO's question, and that would put like not just me in a good light, it would put the whole entire company in a good light, right? I was only there for a short period of time. I had to leave a legacy for myself, but also a legacy for everybody else to continue moving forward, right? And we have to think about what does the company look like once we've left, and how do we make sure that we keep it in a good position so that the company can keep evolving and moving forward after we've all moved on. We're not going to stay in a job for 30, 50 years. So the bit that everyone's kind of been waiting for, like, how did we actually do this? So we started with infrastructure, right? I told you before we had these kind of environmental schizophrenia where everything looked completely different. So we decided to use Terraform because Terraform has strong AWS support to start with, but it's also declarative, right? We can declare everything that we want. We can write all this lovely code. Some people may or may not be able to read it. That's a different problem. And it's it's about kind of architecting our infrastructure for the future, right? But what we wanted to do is we wanted to focus on this kind of modularity and reusability, right? Because one of the things that we wanted to make sure about, if we go back to what I was saying earlier, is this developer and platform level war, right? If we actually put our arms around them and said, look, we'll work with you. We understand that you do actually need some infrastructure to run your applications. Let's make it relatively easy for you, and we can all live harmoniously. Well, that was the theory anyway. So we were kind of laying the groundwork, essentially. So we established what we called TF modules. TF modules, centralized repository for all Terraform modules. Right, this became our kind of single source of truth. I called it the infrastructure catalog because, like, C-level executives love kind of buzzwords. So he went around saying, infrastructure catalog constantly to different people, and they just kind of, with glossed faces, went, sure. So we had this infrastructure catalog, right? And it reflects all kind of possible options. So as a developer, you had a suite of options available to you. You could use them. If you wanted to create another potential option in our catalog, you could. You could create a pull request. It would be reviewed. There was a bunch of other things that we'll get onto in a second. It may or may not get approved. If it doesn't get approved, we'll work with you so that it does get approved. All right, and this is the start of the transformation of cultural collaboration, right? If we're now starting to put our arms around people and say, we understand that not all of the applications just require you to be able to deploy and have a CI/CD pipeline. There may be a little bit more to it. So then we brought in this concept of Terraform roots. So what Terraform roots are is essentially executable pieces of Terraform, right? So this could be one single module, or it could be a collection of modules that kind of come together to like orchestrate a specific part of the application or the application stack. So the idea around this was everyone had an S3 bucket as our kind of backend, but what you'll notice is the bucket and the DynamoDB table in this instance have platform engineering. It's going to look slightly different when we start to talk about product teams. They have their own state, they can do their own things, they can mess it up, don't come near us. Right, you can reference some of our variables and some of our outputs, but you're not going to like mangle our Terraform state. You can do that in your own area, and we can come and help you fix it. Right, and it was about, like you said, right, fracturizing and breaking it up into pieces so that people had empowerment to do what they needed to do, but also didn't break the wider piece of the puzzle. And there was SMEs and experts in different areas. And this kind of gave us the approach to be completely flexible, right? It gave us good granularity and like balance this specificity with reusability. And then this step, in my eyes, was like one of the most crucial steps that we started with, right? And it was to create these, what I called developer-friendly Terraform modules. So these modules weren't just kind of about efficiency. These were a contract between the platform team and the engineering team, right? And once you have a contract and it's signed, you kind of have something to point back at when you say, why does this module have this output and this variable, et cetera, et cetera. So we had a number of these. This is just an example of a couple of them. And the idea here was that every platform, every application and product team could leverage these modules. They could choose to use an auto-scaling group if they wanted to. They probably didn't. But they needed an S3 bucket and they needed an IAM role. And if we could construct and put all of the platform level knowledge into that and just get the abstraction right, we were kind of onto a winner. And here's an example, right? So this is for log ingestion. And they are taking they're taking the application S3 bucket, they create an S3 bucket there, and then they have an IAM role to be able to read and write to it, right? And behind the scenes, they don't need to care about how it works, right? They just know that they need to provide these variables, and they'll get these outputs. And all of the modules had documentation. We used something called TF docs, so the documents would kind of write themselves. They'd be able to see all the inputs and the outputs, et cetera, et cetera. So they could read it. They didn't have to come and clamber around people's desks and ask them how things worked, right? Kind of going back to tribal knowledge, we wanted it all kind of documented. So Terraform kind of solved our infrastructure as code needs, but we needed something like that's job was to make this whole thing developer friendly. Right, and that's where kind of Atlantis came in. So Atlantis was kind of key for us to automate all of the Terraform and all of the infrastructure changes by pull request, right? And this integration was a game changer because now we're starting to bring GitOps principles and developer workflows into making infrastructure changes. So if the application developers did need a piece of infrastructure, they knew where to go now, and they had a kind of playbook to be able to run through. So this is an example output. So you essentially make a bunch of changes for the infrastructure that you want. You construct a pull request. Atlantis works its magic, essentially does a Terraform plan. If you're familiar with Terraform, you're going to know what I'm talking about. Essentially says the changes that you're about to make. You or many people have to approve those changes. That could be one person for development and staging. That could be 2, 3, 4, 5, 6, 7, depends where you work. Number of people that you need for production. And then all you really need to do is the developer just needs to run Atlantis apply. And lo and behold, Atlantis does all of the stuff behind the scenes, runs Terraform apply, and then your pull request gets merged, right? And that's kind of brilliant, right? There's no manual Terraform runs, no introducing kind of human error. There's no like, oh, I don't have the key to the kingdom, but Steve does because he's a platform engineer. So let's go to Steve's machine because Steve will definitely be able to run this piece of Terraform code on his machine. Like all of this starts to go out of the window. And like it layered on this level of security, right? Because we could control who and who didn't have the ability to run Atlantis supply. So people that thought they had the ability to run Atlantis supply in production turned out they didn't, even though they got the approvals, right? So we started to have this audit trail. And this is going to become really important when it comes to actually how we audited changes. We had a change log of all of the things that were going on. But we had Atlantis, and that was kind of great, right? It was streamlining our workflows, but we needed something better. We're running in a bank, so bank is 2 words: security, compliance. That's all they care about. Everything else, yeah. And that's where Fugue Regular came in. So how did that kind of work? Well, the idea is that we still have Atlantis doing the plan, but the plan now, we save that plan as JSON. Once we have that as JSON, we run a set of policy checks against it. That could be just normal ones that Fugue Regular had for AWS. That could be ones that the security folks wrote. That could be the ones that the application developers wrote, the platform engineers wrote, et cetera, et cetera. If you run them and all of your policies passed, great. You get a big green tick, and you can go to Atlantis apply. If you didn't, then you've got a problem with it, and you kind of need to go and fix it. And this caught a number of our security and compliance issues, right? And we're building compliance in from day 0. So we were compliant whilst we were building the platform, and we knew that we would continue to be compliant after we'd built the kind of V1 release. Right. So we've kind of tamed the infrastructure beast now, and we're kind of onto the next challenge. And the next challenge is kind of application development, and this is where it gets a little bit sticky because now the application developers have a lot to say about how they want to do this, which they can have, right? But we said, okay, well, we want to drive everything from Git. We had these principles that we would lean on. And we needed a tool to be able to do that for us. And there's a bunch of tools, right? And Flux is going to be this kind of GitOps orchestrator. And its job is to do one thing and one thing only. We define the stuff in Git. Here's the Kubernetes cluster. Get them to match up. If it doesn't match up, scream and shout about it in our Slack channel, and we'll try and figure it out. And just keep doing that until the end of time. Right, and make sure that everything's versioned and we know what version we're on. So why Flux, right? There's a sea of GitOps tools. This is like there's warfare about which ones you choose. right? The reason why we chose Flux is literally one word, and it's bootstrapping. The bootstrapping was ridiculously straightforward, and you're going to see when we actually bring the cluster up from zero why it became so effective. Right, there's many other tools that we could have chosen, but the bootstrapping was so critical to us because remember we needed to ask that question. How long would it take us to rebuild? Right, so rebuild is starting from nothing. So if we can get the bootstrapping as quickly as we possibly can, we can move forward and answer a bunch of other questions. So it kind of, the ability for us to be able to bootstrap effectively and quickly was like the lighthouse of exactly where we're going. We were going towards Flux no matter what, for better or for worse. But if we built this pipeline correctly, there would be no reason why we couldn't switch out Flux for another tool. It was all about setting paradigms and patterns, and the tool was just a means to an end of delivering a job. So this is kind of how Flux works in a nice, pretty diagram that's way better than the one that I would have drawn. So you perform this kind of Flux bootstrap, and what Flux bootstrap does is connects your Kubernetes cluster to a specific repository. Deploys a bunch of YAML. You're all going to become YAML engineers if you haven't already. Deploys a bunch of YAML, and then a number of controllers get deployed into the cluster. So you've got the source controller, which is essentially where is the source of information? Is that a Git repository? Is that an S3 bucket? Is that a container registry? And then you've got something called a customize controller. Hands up if people are familiar with customize. Okay, a number of you. We're going to talk about customize in a minute. So the customized controller is the way in which we kind of layer on Kubernetes manifests, and we're going to see a lot of manifest and a lot of YAML, so I do apologize. I'll go over it slowly or fast, depending upon how quickly you gloss over. And then there's a number of kind of Kubernetes workloads that everyone's familiar with, right? So we've got policies and RBAC, et cetera, and then we've got this thing called Helm releases, which I'll kind of gloss over and come back to in a second. And then we've got the notification controller. The notification controller is kind of game-changing, right? It's pretty obvious what it does. It just notifies you when things go right, wrong, or somewhere in the middle. This was like we're going to point to tell the developers that it was the developer's problem, and then the developers will point and say it was the platform's problem. This was where it went. We just went to Slack rather than around a table. So this implementation involves like the most important thing was how we structured the repositories, right? So we needed to adopt this kind of multi-repo strategy because we didn't want to put all of the manifests for everything in one centralized location because like all the application developers don't care about how you're deploying Prometheus for your monitoring stack. They can or can't care, but in this instance, if we had like thousands and thousands and thousands of YAML files that were all about different things, it was just going to become a big mess. So we ended up with 3 repositories, right? We had the application source control, pretty obvious what goes in there. We had the configuration repository. Well, that's how I configured different types of workloads, whether that be platform level workloads, whether that be security workloads, whether that be application, deployment manifests. And then we had our kind of third one, which is our infrastructure repositories, right? So once we had these repositories, we kind of had a set of how we were going to go about things. So this is the first repository that we created. So we've created TF modules already, so we're now just talking about Kubernetes now for the next probably 10 minutes. So we started with K8's releases platform, right? So it's pretty obvious what goes in here, hopefully. This is all of the platform engineering workloads, right? And this was the top level directory structure. So we're going to leverage customize heavily here. We've got a number of GitOps workflows that do a bunch of stuff that we'll come back to soon. And then inside of that environment, we had what we call base and then a set of clusters. So these were the clusters that we had. We had sandbox, staging, and production. So for people that are familiar with customize, base is essentially where you put the large majority of your YAML. And then in your, what I would call patches or overlays, you have them in these cluster levels. So the idea is that you basically do not repeat yourself, right? You try and keep it as clean as you possibly can. So you should have way more files in your base than you do in your clusters. So we split up the clusters directory now into 2 different things. So we had cluster resources, which was things like all the boring stuff that no one really cares about, right? But you actually need it to be able to do things like storage classes. So how do I construct storage on Kubernetes? Or a bunch of namespaces. So all of the namespaces were managed by the platform team so that we could put different types of compliance and security rules in the namespace. No one needed to care about that. It just happened automatically. And then we had components. So the components were all the different types of workloads that you could possibly deploy into your Kubernetes cluster. So this was kind of like a workload catalog or a kind of Kubernetes platform engineering catalog. And you'll see here that at the end of the directories, we had the versions, right? And this was so that we could have different versions of different tools in different environments and make it very, very obvious and clear which versions were running where. So I kind of talked about that word Helm release before, and I kind of glossed over it. So what is a Helm release? Well, Helm release is a Flux resource to start with. So Flux is the thing that understands what Helm releases are. And they're essentially split into two sections. You'll see the chart section at the top, and you'll see the values section at the bottom. So hands up people who are familiar with Helm. Okay, everybody, perfect. So the chart, very straightforward. The chart is mostly all of the YAML that allows you to be able to define what you're going to deploy, and the values file is the override of that Helm chart. So we can see here that we're currently deploying the 9.4.7, so we're going to set 9.4.7 in the tag in the base level. We don't want people going and configuring it and changing it to 9.8.5 or something like that. And then our sandbox patch is simply just all of our ingress configuration, right? So it's essentially the domain name for you to be able to browse to Grafana, right? Really, really straightforward. It's 18 lines for you to be able to deploy Grafana to a sandbox environment. And we had a naming strategy for the endpoints, but we'll kind of gloss over that bit because that's not really important. But you can see here that we've simplified the way that our patches look. So when we start to, if you think about how we deploy a sandbox environment and turn it into a staging environment, it's kind of a glorified copy and paste in a massive sed statement, and then we just have staging. And then Customize has this concept of a customized.yaml, and the idea is that we inherit everything from base, and then we pass in our strategic mergers, so essentially the diff between the non-environment specific config and now the environment specific config. So the kind of question that everybody ends up asking me is like, how did you do secret management? Did you store your secrets in Git? Oh no, I don't think you should store your secrets in Git. There's many, many ways of doing this. Granted, there are many, many ways of doing this, but like Flux and SOPs is kind of like this nice thing that works in harmony with each other. And we had a K8 secrets repository, right? So why did we have a K8 secrets repository? Everybody should be able to create secrets for the thing that they needed to create them for, right? Whether that be the security team needing to pipe logs to insert random SaaS provider here, or your application needs to be able to talk to something to be able to configure banking connections. We wanted to have a single place where all of the secrets lived. Previously, I'm not kidding you, secrets were on people's laptops, and they used to like kubectl apply -f file. Yeah, that's like a compliance and security risk nightmare. Or you could do what they also had, which is their centralized CI/CD system. They used to just like FTP files to that server and then get their CI/CD system to like kubectl apply -f and then just this horrifically long directory structure .yaml at the end. Yeah, we weren't doing that. That wasn't going to fly. So we essentially had a K8 secrets repo, right? And you can see the structure looks kind of loosely the same. If you take what we just saw before as customize, we've replaced that directory with the name secrets, and the internals of it will look the same. But how does this work? So SOPs configuration is essentially one sops.yaml file that says, when I see a path, so if you look at the top one, that's basically the platform engineering cluster, I want you to use this KMS key, role, and ARN to decrypt the secret. So we're going to encrypt the secret, we're going to store it in Git, Flux is going to sync it, it's going to go to KMS, get the KMS key, KMS will decrypt it, and then store an insecure base64 encoded string in your Kubernetes cluster for everybody to be able to read. Glorious. So, like I said, directory structure inside of secrets looks relatively the same. And then here is a deliberately impossibly difficult to read encrypted secret, but you can see it looks nothing like a Kubernetes secret that you've seen normally, right? So all you can see is it's got the ARN and when it was created. And we had a make file that wrapped this, et cetera, to make it easy. You could decrypt or undecrypt the whole entire cluster if you wanted to, or you could decrypt and encrypt just the single thing that you wanted. Why did we go with this approach? Well, every developer now has the ability to be able to communicate with AWS, so they all have their own IAM. And we could now use IAM to say, is Steve allowed to encrypt and decrypt secrets in production, yes or no? Or, like, Steve has left the company, should Steve still be able to decrypt, right? And we had some way of being able to contain who and what had the ability to do certain things inside of our infrastructure. And then, like before, I said it was relatively easy. So the Flux configuration, we had the customization here, and you just put decryption provider SOPs, and it goes and figures it out, right? It understands and is able to read SOPs encrypted secrets. So we've done secrets now, we've done platform level workloads. Now comes like the controversial one, which is the product teams, because every product team wants a slightly different repository layout, and trying to get some kind of level of consistency in here was literally like Takeshi's castle, trying to get like and dodge everything that we like. There was so many things that people were saying and wanted. So what we said is we're going to set a set of guiding principles, right? You have to be able to interact with our repositories, so we have to be able to interact with yours. That's fair game, right? We're bringing this culture of collaboration together. So what we're going to do is we're going to give you our repository whether you like it or not. We didn't tell them that, we just structured it in a way that they kind of felt familiar with. So we said, you know what, this is the top level that you're going to get. They didn't know that it was the exact same top level that we were getting in K8 release of secrets, because they didn't look. But this is relatively easy to understand, right? They can understand what they're putting in their sandbox environment. They can understand what they're putting in production. They can move all of the heavy workloads that they used to copy and paste between like all of the environments. They now move that to base. We heavily lent on the word do not repeat yourself, and we said, look, you're not repeating yourself with this structure. Please just do it, otherwise you're going to make my life a living nightmare. And this is what it looked like, right? So we had the same kind of Helm releases again, but this time at the top you'll see we had like a back-end chart. So the idea here is that we had a chart that was defined that everybody would use, and that was like all of the SMEs that knew stuff about Cube kind of came together and structured this chart. And then it was about, remember before I was talking about the contract, so what were the values files and how was that kind of values file structured in such a way that it was easy for the developers to understand, like, yes, I wanted this, and no, I don't want this. And then it was just for them to define the things that they should be caring about, right? They should be caring about CPU and memory. Whether they did that or not, we can kind of come back to that in a minute. But this is their world. They live in this world now. But one of the things that we didn't do in the base Helm release is we didn't set the image tag, right? Because what we didn't want is like 1.15.9 to be deployed to every single cluster because someone forgot to do the override. This is a lesson that we learned after we actually allowed them to do this. Different incident, different outage. It was my fault. This was the way that we stopped that from happening. So in CI, we said all of the base Helm releases have to have v0.0.0. We created the CI job. We stopped everything from happening again. And then we had the patch, and you'll notice here that there's no image tag, right? There's an image tag here, but you'll see that we've got some kind of semantic versioning. So how are we going to perform automatic image updates, right? That's all the developers cared about. How am I going to do CI? How am I going to ship the next feature to production? So remember I just showed this, right? We've got semantic version, we've got this tag, and then we've got this like horrifically long comment that's like a little bit difficult to understand. So Flux has the ability for us to be able to do automatic image updates, and it starts with what we call an image repository. An image repository, relatively simple. Where am I going, and how often am I going there? That's it, right? What's the image repository, and how long? How often do I poll? Then we have an image policy, which essentially is now saying, now you've given me a repository, what tags am I going after? If you don't set this, you're going to get timeouts, you're going to get rate limited aggressively. Like, please, if you're going to use Flux, definitely do set this. Otherwise, you're going to give yourself a whole world of pain. So this is going to only pull 5.0.x image tags. Then you have this massive long thing, which is essentially says, okay, if Flux sees a new version of this, once it's deployed to this version, what does it do? So it's going to write back to Git with this long message here. It's going to push it to the main branch, and everyone's going to live happily ever after, right? The options that you have available to you, you need that comment block at the end, and that's essentially saying, like, where's the image policy and how specific am I being about the image policy? If you don't set that, the magic doesn't happen. I also learned that lesson as well, because I was sat there for hours and hours trying to work out why Flux wasn't automatically deploying the new version of my app. It was because I didn't have these comment blocks. So here's an example. You've got the repository here, and then you've got the tag, and he's specifically said here that the first section, this section here, that's the namespace. The next one is the name of the resource, and then the final one is the thing that you care about. So do you care about the name or do you care about the tag? So the kind of structure hopefully is like clear, right? We've got this kind of audit trail from commit all the way to production deployment. But like now we need some kind of seamless CI/CD pipeline, because if we like F this up, like no application developer is going to talk to me ever again. You can have all of the magic that you want, but all they cared about for about 4 weeks was like, we need the CI/CD pipeline. It's going to be our baby. Leave us alone. Why are you bringing GitOps in the first place? So we started with the Git repo. They chose Concourse. We ran Concourse in a centralized management cluster. It was their choice. They looked after it. They deployed it. It was a Helm release. It was managed the same way that we manage everything else. We performed a Docker build. That would be tagged dev dash some kind of semantic version, whatever semantic version that they wanted, and then that would be pushed up to the registry. In the meantime, we've got this nice image update automation, so Flux is just sitting there looking for new images. Flux finds it, it patches the Helm release in the cluster. It's the thing that does the kubectl apply -f, not the CI/CD box, and then it commits the change back to Git, right? So you end up with something that essentially looks like this. So on a specific day, at a specific time, we upgraded this sandbox application from 1.8 to 1.9, right? Boom, done. Right, we now know what the hell's going on every time. It's not like who deployed the latest version of this application, when did you do it, who was the person that did the change, whose laptop was it on, does the person still work here? Right, all of that kind of just disappeared. We've got everything and we're driving everything from Git. So now we have this kind of process in which we can deploy applications. We needed this kind of wait job, right? And in Concourse, we needed a wait that essentially said, how do I know that the next version has been released, right? And because we had a very strong labeling taxonomy that I don't talk about in this talk, of how workloads were labeled and what labels they had on them, this became relatively trivial, right? For each individual application that you had, you would look for the name of your app with a certain label and the version with the version that you're specifically expecting, right? After it's found it, we did this glorified thing called testing. I kind of gloss over that. I like to test things in production personally, but developers don't and shouldn't. And then to deploy to UAT, we simply just re-tag it with UAT-star, right? With the semantic version again, right? We just rinse and repeat for as many environments as we want, right? We've got this pattern and paradigm. Simples, right? But like some smart ass came up and said this, right? So what are you doing about Kubernetes changes? You've done all of our applications, but like what about things like upgrading Kube or like changing the version? So I suppose we probably had to have a way of being able to defend that. So we leveraged a tool called Pluto from the guys at Fairwinds, and this does deprecation checks. So it essentially says, this is the version that I'm currently running. I'm about to deploy this manifest. Have I got any deprecation checks? Yes or no? So we would do this like N+2 versions in the future, because hands up anyone that remembers the 1.16 release of Kube. Right, so they deprecated about 5 APIs at the same time, and it was an horrific cluster insert swear word. And I didn't want to get into that mess again. So we just constantly kept driving this. So this was on all of the Kubernetes repositories that we had. We just drove it out and made sure that moving forward, when we upgraded to a new version of Kubernetes, we weren't at least going to get caught with this problem. And then we used kubeconform. So not every developer is a Kubernetes developer, right? It's a Kubernetes engineer and knows all of the Kubernetes like indentation and all of the right words to use, et cetera, et cetera. So we had some way of making sure that we'd stop mistakes from anyone or wherever they came from. So kubeconform's job is essentially to say, do I conform to the Kubernetes spec, yes or no? So I like to think about when you deploy to Kube, you've got kind of 3 stages. You've got like before I deploy, when I'm deploying, and like post-deploy. So we're now dealing with the before I deploy. So if I can figure this out and stop things merging to the cluster, it's less bother that the platform engineering team's going to get, and there's going to be some educational exercises that happen to explain why you're not conformant, right? And that's where we start to learn and share the lessons. And then we talked before about like this concept of a Helm release, which is this higher level abstraction, but actually what you're doing underneath is you're really doing a Helm template and then piping it to kubectl apply. So the Helm template is really the thing that we needed to check. You can't validate a Helm release because you're not deploying a Helm release. So what this did is it essentially took the Helm release, abstracted the chart, went and got the chart, got the values that you applied it, mangled them together, and then run all of the checks that I've just showed you against them, because that's really the thing that we're deploying. So kind of how do we put this all together? Well, we start with AWS, we layer on Kubernetes, and then the first thing that we deploy is the KX releases platform. We target a specific directory there. And then that brings up this first repository. Then we layer on what I called KH Releases Corp. This could be any of your product teams. KH Secrets, KH Kafka. Right, this should hopefully get very, very boring right now. And Istio Releases, because if you're not running a service mesh, then you're not really doing Kubernetes, apparently. And that's a kind of any directory and environment, right? So if we can, now we know how we bootstrap a cluster, right? We have the kind of playbook. So now we've got sandbox or development, we can do production relatively easily. So I'm always a big believer in this, right? Cluster creation should be as thrilling as brushing your teeth. That's what I told like all of the platform engineers, right? The real excitement is like what you're actually putting on top of it. All of this is kind of boring, right? It sets the foundational ground level so that you can actually build your competitive edge on top. And like the most valuable clusters are the ones that you kind of just stand up and forget. And like we need to make the complex simple, right? That's the whole idea of why we're here. So like it wasn't all like chocolates and roses, right? We did have a number of challenges. So the first one was like we had resistance to change, right? Some team members, particularly ones that started at the beginning of the project, were kind of hesitant for someone to come in and kind of wrestle control of how they did their manual processes of kubectl YOLOing on their laptops. And then it required us to learn new skills, right? And I was learning new skills when I said let's choose Flux, but also we had to like heavily invest in training all of the engineers and all the developers, right? And we kind of sought time and money from the community to actually get them to come in and help us along with this journey, right? This wasn't just me and a bunch of other people trying to do it. And then we also had like these legacy systems, right? Because anyone that's worked in banking, there's a bunch of legacy systems and they don't lend themselves to this like at all. So we had to modernize the way that we did that and then bring it to GitOps. We couldn't just bundle GitOps on top of it and say that we were doing GitOps for these legacies. And then we obviously had the other ones, which was we had to explain to the business that there was going to be this initial slowdown, right? We'd slow down right now to speed up in the future. We had to be really careful about how we painted this because we had to keep shipping features, but we also needed to be building the new version 2 of the platform. And then we had to maintain business continuity, right? We were changing the engine of an airplane mid-flight with passengers on it. We had to be careful about how we did that. And how we did that is kind of a completely different talk. But like kind of as the dust settled, right, we found ourselves in this kind of new reality that was like drastically different from months and months of the past. And that question that like I used to get cold sweats about and worry about what I was going to do, I had the answer, right? I could walk into that room with confidence and I could say, you know what, I have an answer. And I have better than an answer. I can actually show you it in real life, right? And there's a number of reasons why we did that, but essentially we had the infrastructure as code, we had the automated deployments, we had this improved collaboration where like developers and platform engineers were actually like harmoniously like envisioning them like linking hands and like skipping around the office, which was like unseen and unheard of when I first landed. And then we were doing compliance and security in the middle, like right at the beginning, right? And then the final most important one is we had this faster recovery process. But like that only really tells half the story. Like the most important thing for me at least was like the transformation that I had on the people and the culture, right? GitOps is just a tool, right? It's just a means to an end. But like the finger pointing and blame kind of stopped like immediately, like in its tracks. And it's now been changed into like this collaborative problem solving. And everyone kind of becomes innovators because everyone understands how the bigger machine works, but they understand how their piece of the puzzle works in collaboration with other people's. And the teams were continuously optimizing and evolving, right? And like I said before, this question was not a problem anymore because we actually started to practice disaster recovery drills, right? Unheard of. Right, we actually practiced failure constantly. So we said, look, we're going to lose regions, and then after we lose regions, we're just going to lose like 2 regions. And can we stand up in like we're running in Europe? Can we stand up in the US? How quickly can we do it, et cetera, et cetera? And these were all good kind of like cards to play when I was playing poker. When I was in the meeting room, like, yeah, we've already tested that. Yeah, we do this every month. Yeah, we do this every quarter, et cetera, et cetera. And like our GitOps journey, right? We started in the trenches of like this warfare where there was team clashes and cliques like all the time, and then we faced our Apollo 13 moment. And like I want to leave you with a couple of things, right? Evolution has got no expiry date, right? Even legacy systems can become like cutting edge platforms. And our biggest pain point was like a signpost of like this great opportunity that we had in front of us. And I think asking the right question is more important than having all the answers. It's the questions that you don't ask means that you never actually get to implement the answers. And like the cultural change was huge, right? Like we shifted left, and we had to do a lot of that. And then finally we were continuously improving, right? The perfection's like this journey, it's not a destination, like it's constant, continuous evaluation. So like now I want to pass the torch to you, right? What's the questions that hold your organization and is afraid of you? And like what inherited chaos is holding you back in innovation? I have another talk, shameless plug, tomorrow. And you can reach me here if you want to talk more. Thanks.